All right, one more idea to look at with breadth first search, the idea of connected components. So let's consider just undirected graphs for now, and let's, for example, take this graph I have here in the upper right. So you might notice that this is not a connected graph, meaning I can't get from every vertex to every other vertex, but I can group them into components that are all reachable. So I got the nodes that are black, the nodes that are blue, and the nodes that are green. Those are the different components of this graph. So our idea here is to compute all of those connected components in big O of m plus n time. And really, a component is just any group of vertices that can reach one another. And you might do this to see if a network has been disconnected, for example. So if I am at S, I could ping every other node, and if I only hear back from these two, that means that the graph has been disconnected and I need to do some work to repair the graph itself. Okay, so I do want you to think about this, and then we'll pause the video here and we'll come back and I'll give you a solution to this problem. But basically, how can you use breadth first search to find the connected components? All right, well, we have our find components function. It takes in the graph. We don't have to give a start vertex here because we're not just trying to find a single component, we're trying to find all components. So let's say this entirety here is our graph G, all of those vertices. So we'll have a list of components, and we're going to start by marking everything as not having been found. And then we'll say for each vertex in the graph, if it's not already been found, then we'll start a call to breadth first search. And breadth first search here has been slightly modified from before in that it's actually going to return the vertices that have been found. So before we were returning distances, and then before that we were returning the ones that are found. We're back to this version, not the distances version. So we call breadth first search on each vertex if it's not already been found. And we're going to create a new component by just looping over these newly found vertices and just adding those into a set here for the current for this current iteration. So for example, if we start at A, we're going to find C and we're going to find F, and then we'll just group all of those into a single set, the A, C, F set, and add that set to the list of components. So components.append. And then we say for each W in the new component, we have to remember to mark it as already been found. So we'll mark A is found, C is found, and F is found. If we don't do that, we might start at C later on and find the same component again. Then eventually we will return all components. So if I'm doing this alphabetically, I've found A, C, and F, and then in this next iteration here I would do B, and I would find B, E, I, and H. Mark all of those as having been found. And then in the next iteration here of the for loop again, I would start at C, but C's already been found, so I skip over it. So I'll skip over it until I start at one of these. So the next one would be D, and then I would find that set.